Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, Computer Science and IT. This is Malisham Devasane. I'm working as an educator in an academy where in this session I'm going to explain the difference between undecidability, uncountability and enumerability. So we have so many words in our theory of computation. Among these three words, we should have a clarity because some people might assume the undecidability is uncountable. Even I was assuming earlier, but after looking at examples and reasons, you must aware of the reason, the difference between these various words. Okay, without wasting our time, let me introduce myself so that we can start our session as soon as possible. Yeah. I have worked at various institutes in India and I have traveled many cities to train the GATE aspirants. And today I have almost more than 12 years of teaching experience, guided more than 1 lakh students. And before starting my career in GATE, I have completed my MTech from IIT Bombay. Here, the popular courses that you can find on Unacademy like TOC, C programming, compiler, and some of the classes for discrete mathematics and algorithms I've taken, and also various classes for combined quiz like all 12 subjects. Also, I have taken many quizzes. You can go and watch them freely on Unacademy. So this is my referral code DEVALIVE to get 10% discount on Unacademy, which will help you to prepare seriously. If anybody is serious in GATE preparation, so better to join Unacademy for Plus or Iconic subscription, where you will get an access to the top educators of in India, where every course taken by the top educators. So you will be easily gaining the knowledge and quickly you can resolve your doubts because of the benefits of Unacademy subscription. The Plus and Iconic, why we recommend to go for subscription, because every class is a live class and you will have interactive live classes so that immediately you can resolve your doubts, and you will have weekly test doubt solving sessions and structured courses to learn every subject systematically. And apart from these benefits, you can attend unlimited number of live classes based on your subscription plan. And Iconic, you will have all benefits of Plus. Additionally, you will have a coach and study material plan and many other benefits too. So these are the benefits on joining Unacademy from my classes, but you have thousands of classes freely accessible on Unacademy, and you can unlock all of them using just referral code DEVALIVE. In case you have not visited, visit this URL unacademy.com/devagatecsc and unlock your free plan. You can access to all thousands of free classes on Unacademy too. If you are using mobile, you want to install the app, go to Play Store and search for Unacademy Learning app and click on install, and right away you can access all the classes. And what is the advantage of joining Unacademy? You will get an access to India's top educators and some of the best faces that you see here, right? And if you are using browser, choose Goal, Gate and ESE. Click on get subscription if you require, or you can search before that login using a referral code DEVALIVE. So this is the benefit. These are the benefits. You have Plus and Iconic as I have discussed so far. Click any one of the plan and you can look at, if you are going for a Plus subscription, you have various plans like 1.5, 2 years plans, and you can look at the prices. The prices for each plan is different, so choose as per your requirement. In case if you see more price, don't forget to use DEVALIVE referral code. And Iconic also has a different plan like 6 months, 1 year, 2 years. I'm talking about 1 year and 2 years, and 1 year price is 45,225, 2 years price is 66,600. Yeah, these are the plans that you have if you want to join Unacademy, guys. All right. Yeah, good evening. Yeah, Merry Christmas to everyone. Yeah, Satyajit, good evening. Devraj, Shubhasri, Samir, good evening. Sneha, good evening. Yeah, good evening. Yeah, please like the session before starting. If you are enjoying our sessions, please like the session, guys. In case if you are having any friends, you can refer the new batches which are recently started, and for electronics and electrical and mechanical civil is going to start soon, and CS and IT we will announce soon. Yeah, tomorrow if anybody want to access my free classes, tomorrow morning 8 a.m. strategy for last 1 month preparation on Unacademy, guys. You can attend Unacademy free class at 8 a.m. 9:15 a.m. we have complete strategy for on compiler design if you are preparing for 2022 and 2023. Weightage, important topics, and how to prepare, what textbooks to prefer, and this is a very important session who are preparing for 2022 and 2023, including if you want to attend 2021 also can be you can attend. Yeah, 11 a.m. I have a plus course which is a paid course on Unacademy, guys. So these are the sessions that I'm going to take tomorrow. You can attend. And after this session, today I'm going to take one more class after this, 10 p.m. You can access free class on Unacademy. It's about arrays and pointers in C language, guys. So 2 hour session, 10 p.m. to 12. Yeah. Shubham, good evening. Bhargav, good evening. Good evening, guys. Good evening. Yeah. Thank you so much. Yeah, it's not just last day. We have so many practice sessions, Subhasri. Every Saturday, Sunday, I may take one session. Next Sunday, this Sunday, I'm going to take the practice session on TOC. This will continue till the exam. Don't forget, we will have the sessions on every Saturday and Sunday. Sometimes I take on both the days, sometimes I take on only Sunday. So depends on the my announcement, you can attend the classes. Yeah, Shubhasri. Chalo. What we had in previous sessions, what we have seen Turing machine decision properties and how to identify some of the problems and some of the languages too. And in this session, I am trying to plan the difference between these three words, decidable versus undecidable. So in the undecidability, we have these two words, countable and uncountable, and enumerable versus not enumerable. Everybody? Yeah. So these are the important words where you may or may not have awareness of these words. First one I have explained, and third one I have explained, but still you need to have a relation properly. So I want you to understand these three words properly. Three words properly. Let's start. And I hope you understood decidable versus undecidable language. Everybody? Decidable set. Decidable in the sense, you have an HTM to accept, HTM exists. Undecidable in the sense, no HTM exists. Very simple. TM may exist, may not exist, we don't care. Right? Decidable in the sense, you have logic for valid and invalid members. Logic exists for both valid and invalid, right? And here no HTM means it's guaranteed that logic never exists for both of them. Either exist for only valid or not exist for valid. Two cases will come here. Case 1, logic might exist only for valid, or logic not exist for valid. Invalid, second case invalid may or may not. First case invalid, no logic. Logic not exist for valid. Logic only exists for valid, that is RE but not recursive. You know it. This is for RE but not recursive. We have seen this. I am revising it. This is the not RE problem. Everybody, this is about decidable versus undecidable, guys. Here undecidable word is too dangerous because Even though you have a Turing motion sometimes, we say undecidable. The reason is you don't have halting Turing motion. Everybody? The first point, Turing motion exists. Second point, TM not exist. But anyhow, HTM not exist. For both of them, no HTM. Because you can't prove the logic exists for both of them. Clear? Undecidable, another name is recursive language. Decidable, another name is recursive language. Yeah, this is about decidable, undecidable. We have seen some of the examples in the previous session. Right. If you want to practice some of them, look at how do I practice? How do we practice? L is equal to DFA, comma, 0 such that DFA accepts string W. And do not confuse with the pair, guys. This is something that I want to show you how my input looks like. Everybody, how my member looks like. My member machine, something like this. Don't worry about it. Don't worry about it, guys. This might be my one valid member, and here you will have a DFA2, something like that, comma 0, and so on. DFA1 I am showing here. And here, this is the membership problem. What is this, guys? This is a membership problem. You know that membership problem already decidable. So any input you give me, if you give any input may be just DFA or input can be DFA comma 0. It's your choice. It's your choice. So if you give an input DFA comma 0, then I can find out that DFA accepts W or not. W is already there inside. Assume that W is fixed. Because all the DFA I might be checking same string. That is the reason W I am not giving every time. Okay, W can be fixed for all the checking, all the DFAs checking. So I can use the membership. I can use the membership to verify every DFA. Whether it accepts W or not. So S means DFA accepts W. No means DFA doesn't accept W. Right? Whenever you get an S, that means it is a valid string. It's a valid input. Who is the input here? Input is, this is an input, guys. Input is a pair. And this is invalid input. Means DFA doesn't accept W. Everybody? So this is about decidable language. But we are depending on a problem, that is whether DFA accepts given string. And we took that problem. If that problem is decidable, then this language is decidable. This language name is set of pairs, where every pair has a DFA that accepts W. Everybody, this is how we speak about the language now, guys. Clear this point? We have used the existing knowledge. Yes. Devraj, it's true. Undecidable means Turing motion may or may not exist. Yes. But HTM never exists. Now for this I can show you halting Turing motion because I have a logic for both of them. Because we know that logic exists for both of them. No use. That 0 is a further confusion. I can keep 00. I can keep 1. That doesn't matter. I can keep that less than greater than symbol. I can write parentheses. It's all just for the confusion. मैं कुछ भी बोलूँगा, ऐश बोलूँगा, कुछ भी, उससे confusion नहीं होना चाहिए आपको. आपका problem कुछ और है. I can write my own ash, comma 0 such that DFA accepts W. There is no use of ash and 0. Just append them in every input. That's all. They don't have any problem with them. You might be assuming that your input in this fashion, DFA is given as a one parameter as 0. But your algorithm is just working on the first parameter. This is just for the confusion. They might require for some purpose, but you do not know it. Just ignore them when you don't need them. Just ignore them when you don't need them. Right? Everybody, there is no use of 0 and hash because there is no significance in them. Just for the confusion, they might add anything. Just your algorithm should work on the first parameter only. Everybody, same problem. Same algorithm will decide this problem also. But this problem is different. This is not set of DFAs, set of triplets. Where every triplet as the first parameter is a DFA that accepts string. Yeah, Akhil, thank you so much. Everybody, is it clear? It's just set of triplets where every first parameter of the triplet, that is the DFA, accepts a given string W. String also given, but that might be taken inside because it's fixed for everybody. Right? Your focus is only on the first parameter only. Focus only on this because other parameters no use. Sometimes it might be useful when I might give an input DFA comma W where DFA accepts W. This case, two are important because I am going to give every time a different DFA and a different string. Then you should work on these two inputs. Now this is one input, but in which a pair is an input in which two parameters are there. Now you have to check whether is W belongs to language or is W belongs to language accepted by DFA. W is also in the pair, DFA is also pair in the pair. So both are important now. Both are important because W is also provided inside the pair. Now W is not fixed for all the inputs. In the previous problem, W was not mentioned in the pair because W is the same for all the inputs. Maybe I am asking, is that every DFA accepting 00? Then 00 is a fixed. No need to give in every pair. Now I might change. First time I ask, I will give one machine. I'll give one machine. Is it accepting AB or ABA? Next time I will give another input. I will ask, is it accepting ABA? First time you say yes because it accepts. You can say second time you say no because it doesn't accept. For this you are running a membership algorithm. Right, everybody? Yeah, whenever you want to ask any problem, specify your problem clearly. Don't say randomly, if I keep RL inside, not RL inside. Ask me exactly what do you want. दुनिया में infinite problems है. What are you thinking about? How do I know that what is your problem, right? So write clearly what is your problem name. Then I will talk to you. Okay, fine. This problem is also decidable, guys. I can use the membership. समझ लो, this is not about the regular language or not. It's about the every member is a triplet or pair or DFS. It depends on your representation. Everybody, this is about decidability or undecidability. Right? Even if you want undecidable now, I can give you one example now. Look at Turing machine comma W, where TM accepts W. This time this problem is undecidable because I cannot understand. You might give some Turing machine, let's say 1 and some W1. And do you have any algorithm to check? Who will have a logic? If really W1 accepted by T1, then definitely S has a logic, no doubt. Because the TM1 also at final state, W1 accepted by T1. Right? If it is not accepted, W1 not accepted, we really do not know how to tell that because Turing machine may not halt, guys. No logic for this. Logic not existed to show it because Turing machine may or may not halt. Everybody? Yes, this problem is undecidable but semi-decidable, guys. This is RE but not recursive language. This language The set of pairs is a language now where each pair has a Turing motion and string RE but not recursive language. And you can say this problem is undecidable but SD. Everybody, it's a new problem. And some people might design just take an input only Turing motion if W is fixed for everyone. Right, come on. Okay, before this last problem I'm taking, as somebody is asking a new problem in the world. I don't know what do they want to ask, but let's, even they don't know how to write it clear. DFA accepts W and REL accepts W. REL accepts? No. Turing motion accepts, not REL. ये कहाँ से आता? Turing motion. REL कैसे accept करता? Language है वो. REL contains. TM accepts W. Okay. Now tell me guys. Now input is DFA is 1. This is input style. Now how do you check? Do you have any logic? Who will have a logic? Here both of them you have to check. Is DFA accepts W and is DFA accepts, Turing motion. Both you have to check, not one. Anyhow DFA we have logic, algorithm for yes or no. Yes or no? Is TM accepts W? And perfectly yes you can say, because both will alt at final. DFA alt at final and Turing motion alt at final. You want to say both, right? If you are going to keep the pair when both accepts TM, and if one accepts TM, other doesn't accept TM, one accepts, one accepts W, other doesn't accept W, then we don't keep in this language. This is the language, right? If this DFA accepts W, TM doesn't, then we don't keep this pair in the language. That's not the valid member. Who is the valid member? Here, DFA accepts W and TM accepts W, then only that pair present in the language. Which pair? DFA comma Turing motion is belongs to L. Otherwise, any one of them not accepts or both of them not accepts, that is not in the language. But which one has the logic, guys? You know, this will have a logic because both halts at final. But other one, DFA halts at non-final. But Turing motion, no guarantee what it does. Suppose DFA might accept W, but Turing motion doesn't accept. No way to understand. There is logic not exist for this. Everybody, logic not exist for this. No. Who is that? Devraj. DFA Turing motion need not be accepting same language. These are different. This need not be equivalent. DFA and Turing motion, no relation here. You did not say they are equivalent. Remember that. This problem is undecidable, but it is semi-decidable. You have a Turing motion to understand this problem. Yes. Everybody? Okay. These are the problems you can design on your own, but I don't have that much time to solve your own problems. You take care of them. Okay, let's move on to another one. And I don't know how many of you studied countable and uncountable set. You can also watch my previous videos. And countable sets are two types. Here, every finite set is a countable, but some infinite sets are also countable. Some means infinite only, remember. But these are called as countably infinite sets. Countably infinite sets. They have names, guys. Finite sets and some countable sets are two types. Finite sets and countably infinite sets. That some infinite sets are called as countable infinite sets, but uncountable sets only happens for infinite sets, guys. Some infinite sets are uncountable. Remember here, if you want to understand some other way, set may be finite or infinite. No doubt every finite is countable in this direction, and infinite may be countable, or may be uncountable, because infinite is two types. Infinite set is two types. Sometimes countable, sometimes uncountable. Everybody, now the problem is every finite set is countable. That is a trivial. It's not much important for us. But next one, that which is important here, countably infinite set. Countably infinite set. That's much important now, guys. You do not understand, even though you may not have a Turing machine, it is possible to have countably infinite set, guys. Remember that. That is what I am trying to tell you. What does countable means? That's what I am trying to define. मैं ही क्वेश्चन पूछ रहा हूँ, आप आंसर, आप मुझे क्वेश्चन पूछ रहे हैं, मैं ही क्वेश्चन पूछ रहा हूँ. X is countable set. Then why we say X is countably infinite set? It's a mathematical word, guys. If and only if you can show that the X has a bijective with some Y. What is bijective? Don't ask me, guys. Okay, bijective के लिए और फिर बताना पड़ेगा मुझे. And F is a function from X to Y is bijective, where X is already known as a countable, where X is already Y is already known as a countable set. So you have to prove that, I have a bijective mapping with already known countably infinite set. Basically, that why people might take natural set or integer set, that depends on your logic. But no need to be natural set, integer set, but always exist. Everybody, the Y is a trick here. It is a known, already known as countable infinite set. Now I want to know about X. Then I will try to map with already known set, and I will relate as a bijective mapping. Yes, is bijective. Now what is that? I'm trying to help you guys. What is that? You know, in the world, natural set is known as well-known countably infinite set. CIS means assume countably infinite set. Otherwise write it. Countably infinite set. Now I don't know what is Z. How do I prove? Z is what? I'll try to show that, okay, Z is one set and I know N is another set. I will try to show that here to here is a bijective. I will show that because I will show function f and f inverse exist. Everybody, I'll show that f is bijective. Just to prove that f and f inverse exist. Enough. Show that. Or show that f is 1 to 1, that is injective, and f is onto. Injective and surjective. This is another definition. If you want to prove bijective, show that it is injective and surjective, or show that f and f inverse exist. It is your choice. How do you want to show it? Okay, I'm trying to show something. But every problem I can't show you guys. I can only speak. 0, minus 1, minus 2, minus 3, and so on. 1, 2, 3, and so on. If it is your choice, I might take 0 if I want it. So I'm including just to make it easy mapping. Otherwise, you can start with 1. No problem, guys. You can start with 1 also. I know N0 is a countable infinite set in the world. Okay. Now what I do is 0, I map to 0. So I'm going to do the magic. 1 I map to 1, and minus 1 I map to 2, and 2 I map to 3, and minus 2 I map to 4, and 3 I map to 5, and minus 3 I map to 6. Look at that. Something is here. Both f and f inverse I am going to show now. Look at now. If f of 0 is there, then it is 0. And f of x is equal to, Look at all the positive numbers. 1, it mapped to 1, 2 mapped to 3, and 3 mapped to 5. What is the relation, guys? 2x minus 1 when x is positive. Similarly, I can show you that f of x is equal to, when it is negative, minus 1 maps to 2 and minus 2 maps to 4 and minus 3 maps to 6. It is equal to minus, anybody guys? 2x. Because already minus is there. So minus into minus plus and multiply with 2 when x is negative. So this is f. F inverse also you can do it. Everybody, f I have shown you. Now f inverse also you can show this. F inverse also exists. F inverse is a function. I am going to show that. How? You can look at this side. I am going to show here. Now let's try. F inverse maps from n0 to z. You know that. Now let's try. 0 maps to 0. Reverse guys. And even numbers I am trying. 2 maps to minus 1 and 4 maps to, reverse guys, minus 2 and 6 maps to minus 3. Then look at what is the logic. If x is, f inverse of x is there, how do I find the result? Everybody, how do I find that 4 has a minus 2? It is minus x by 2. Everybody, you will get it. Including 0 you can do that. That is for the even numbers. When x is even. This is the f inverse mapping. When f inverse is x is odd, then you have to do something else. Yes, minus x by 2. So I got that. I got something. F inverse of x. F inverse of x is equal to minus x by 2 when x is even. Similarly, now I want to do that for odd. How? Reverse guys. 1 goes to 1, 3 goes to 2 and 5 goes to 3. How do we do that? Odd numbers guys. If it is x, what is the relation? You can see that x plus 1 by 2. X plus 1 by 2. Everybody? Come on. Is that correct? I'm doing it guys. X plus 1 by 2. 2 plus 1. Everybody, 3 plus 1, 4 by 2. Yes. That is x plus 1 by 2 if x is odd. That means I have shown you f and f inverse exist. It means it is the bijective. So z is also countable. Now I can say that z is countable. I have proved it guys. With the help of already known countable set. Here n0 is already known countable. Already known to the world. Clear? But har koi dunya mein guys, please don't try to do one thing, that every countably infinite set, it is hard to prove. But we can talk about them. If you know about, n is countable, n0 of course, even z is countable, even 2n is also countable, 2n plus 1, that is set of even numbers, odd numbers, even prime set is countable, even rational set is the countable, irrational is not countable guys. Rational set is countable. These all are well-known countable sets. And who are uncountable? Like irrational set. We don't have any logic in the world. We don't have any bijective mapping with already known countably infinite set. And set of real numbers, real set, is uncountable. And complex set, the set of complex numbers, is uncountable. Right? These are uncountable sets guys, because they don't have bijective mapping with any known countably infinite set. अरे don't have bijective mapping with anybody in the world. अगर नहीं है तो मैं कैसे दिखाऊं? Not countable. Not countable, it means already I don't have any mapping with non countable infinite set. ये पूछो सर ये countable क्यों है, तो मैं दिखा सकता हूँ bijective. I don't have. What is the definition of uncountable? इनको बताना पड़ेगा. Not countable. When we say it, When we say x is not countable, if and only if there is no y, such that f x to y is bijective. अरे दुनिया में बाइजेक्टिव फंक्शन नहीं है उसको मैपिंग करने के लिए. Y not exist to map. There is no set y which is countable in the world. There is no countably infinite set. Everybody? There is no countably infinite set to map as a bijective. Come on, random stuff. ये पूछना पड़ेगा काउंटेबल क्यों है, नॉट काउंटेबल मतलब नहीं है तो कैसे दिखाऊं मैं, है ना. बहुत बढ़िया क्वेश्चन पूछते हैं यार. ओके चलो, और these things I can come to the point. Of course you can try once you know the definition. I'm not here to solve every question, right? I will try whatever I can do for you, right? So now sigma star, where sigma is equal to a comma b, is a countable because I can show you DFA and sigma star is a set of strings. But second, this is a countable. Here is countable. Which one? Sigma star. Sigma star is countable. And but 2 power sigma star is uncountable. Here it's just not only this, even power set of any countably infinite set, it comes as uncountable, guys. Power set of the countably infinite set here, like power set of n, power set of z, if you want, is they're all uncountable sets. This is an uncountable set. Fine. Now here when it comes to the point every regular is countable. Every regular chodo. Every REL is countable. Every REL is countable. But problem is even some of the not RELs are also countable. Some not RELs are also countable. ये अलग बात है. Computable अलग है, countable अलग है, guys. Everybody? Everybody? And which not RELs are countable? ये बताना पड़ेगा दुनिया में क्या है. Okay, some people are, first thing is you must know set of all Turing motions for the given configuration is countable. Because for any Turing motion we will have a Q fix, sigma fix, right? Turing motion is equal to Q sigma delta Q naught F. For this configuration, the number of Turing motions are, you can easily design set of Turing motions and set of DFAs, set of PDS, they are all countable, guys. Definitely. Now when I ask a problem, TM such that TM accepts W, TM such that TM doesn't accept W. Look at this. This is RE but not recursive. Yes or no? Because membership problem is undecidable but RE but not recursive means countable because it is also REL. REL is countable but this is not REL. But which not REL? Is it countable or uncountable? That I am trying to show. Assume this is L1, this is L2. And do you know L2 can be proved using 2 countables. I can just do set of all TMs minus L1. What do you get? Set of all TMs where each TM doesn't accept W. I'm not going to verify, but I'm going to count it, that's all. Doesn't accept W. I'm not showing you a programmer algorithm, guys. I'm only showing that it is countable. Remember that this is known as a countable. This is countable. And countable minus countable, right? union countable, countable, intersection countable are going to be basically countable. You know that, I think so. Everybody? So from the countable set, if you delete the another countable, you should get a countable set. This is also countable, but it is undecidable, guys. This not RL is a very special in the world, uncountable. But remember, it is countable. I am saying countable. It is countable, but undecidable. It is a countable, but it is undecidable. Remember, no relation like, we have every countable is, you can't say RL. Every RL you can say countable. Here there are some words you need to understand. Every REL is countable. That's true. But every not REL don't say uncountable. Some not RELs are going to be uncountable. That is what I am trying to say. Some not RELs are countable. That I am trying to show with an example how this is a not REL, but still it is a countable. Everybody? It is a very interesting point. That is the reason today these words are not described in easy textbooks, guys. And those people who understood my previous classes, and this is going to be very easy for you. What I am trying to speak about the languages. Everybody? Set of all Turing machine was countable. That was the reason. So set of Turing machine doesn't accept W is countable, but we don't have any Turing machine to show that. Okay, so now I'll talk about this. One example for those people who want more examples, like set of all RELs. No doubt it is countable, because every REL we have some mapping, right? We have a Turing machine, no doubt. But when you talk about set of all not RELs, you cannot. Why? Set of all not RELs, can you understand? This is going to be uncountable. What is the reason behind it? Even you try some other way, like, this can be written as some other way, guys. Set of all languages over sigma minus set of all RELs. You can write that, but this is itself 2 power sigma star, guys. 2 power sigma star is uncountable. If this is the countable now, you can prove this is also countable. But this is, we are proving it from uncountable set minus countable. You don't know what's going to happen. Obviously it is uncountable. Everybody? Everybody? Don't say that previous problem is countable, so this is countable. Previous problem was different. It's about set of Turing machines. Set of all Turing machines was countable. That's why countable minus countable was countable. But set of all languages is not countable, guys. Clear? Come on, guys. Please like the session if you are enjoying these classes. Okay, let me relate. Now, enumerable versus not enumerable. Enumerable means Turing machine exists. That's all. HTM exists or not, I don't care. Turing machine exists. Not enumerable means not REL, guys. Another name only. Not REL only. Everybody? Not REL in the sense TM not exist. TM not exist. Everybody? And this is important. Whenever I have a Turing machine, that set is enumerable. Whenever I don't have a Turing machine, then that set is not enumerable. Very simple, guys. Now I want to relate all of them, because you know this problem, right? This is only REL, another name only REL. Right? You can say semi-decidable. Another name is semi-decidable. Enumerable set also called as semi-decidable, partially decidable. Okay. Come on, guys. Let's move on to the differences. Decidable versus countable versus enumerable. Okay. Before that, let me tell you something. If anybody is new to this platform, guys, let me help them. And what we have here, two plans, plus and iconic. And if you are not aware of this, And the content that we deliver on Plus and Iconic, you will never imagine. Remember the point. When we come to YouTube and when we deliver the content that you have not seen anywhere, definitely we will deliver more than this on Unacademy. When you pay to somebody, remember that. And indirectly we are paying to, you are paying to us. So that's what I'm trying to tell you. Structured courses will help you a lot and you can learn from the best educators in India, and multiple courses for the same subject, multiple batches in a year, and you can come to every batch or you can stick to one batch and study as per your interest and learn from top educators, study with proper planning, what not there in the Plus and Iconic. That's what. Everybody? Right? I think my sound is fine. Let me check, guys. Fine. Okay, keep going, keep going. Now I'm going to help you. Yes, recursive enumerable language called as. Now I'm going to help you. What is the relation between these three? And carefully understand this relation, guys. And we are trying to understand first पूरा दुनिया set of all languages पहले इसको फॉर्म कर लेते हैं. Assume this is पूरा दुनिया, कोई बाहर नहीं है, सब अंदर है language, every language. And I'm writing as this is set of all languages. Set of all languages. Everybody? Set of all languages. Now let me move to here. I'm trying to divide into two classes, like you know that. This side assume not RELs, this side, and this side I'm assuming RELs, all RELs. Now here you know that there are some problems are right. If you are not able to look at this, let me write clearly RELs. Now here we have some specific set here. These are all decidables. You know that all decidable languages. Now which one is countable? This relation we know. We know this relation. From here to here, all RELs but not decidables, or but not recursives. We know that. Now where is countable? And that is so interesting here. Guys. Look at from here to here. This one. It's gonna be countable sets. All countable sets, guys. All countable sets. And this side all uncountable sets. And this is the best relation what I can give you so far based on our knowledge. This is very interesting for us. Decidables are countable. Even RELs are countable. But countables need not be decidable. Countables need not be RELs. Because countables are also exist inside not RELs, guys. Everybody? Some RELs not recursive, but they are also, everybody is countable inside REL. Here, please remember, every REL is countable, but countable need not be REL. Okay, everybody? Countable set doesn't mean that you have algorithm or program, something like that. Remember that. Fine. So this is the most important relation between decidable, countable, enumerable, undecidable, uncountable, enumerable. So let me write, everybody. Can we move to the next? Good. And this is officially the last topic that I'm going to take in Turing immersion, but we don't end up in practicing. So many concepts that I have not covered in these sessions, I will be keep on helping in the practice sessions. Remember that, and give your valuable comments and feedbacks at the at the end of the session, because this is going to help us to to improve ourselves and to reach the audience. And if you are really learning from us, this is very, very important for us, guys, what you have learned from us. And please leave one comment at the end of the video, at the end of the session, guys. Don't forget that. Okay, now understood this point, right? Now let me talk about, if I say, look at the words, can I say any relation between undecidable and uncountable, guys? I can only say every uncountable set, I can say it is undecidable, no doubt. But undecidable is also, here we got answer, actual answer is not real. But we cannot say every undecidable is uncountable. No, we can't say every undecidable not, that, right? Undecidable, I'm writing here, but undecidable need not be. But undecidable need not be uncountable. Some are countable, some are uncountable. This is one point. And second point, every uncountable set is not real. As I said above, but not real need not, but not real may or may not be countable. You know that. Some not reals are countable, some not reals are uncountable. Not real need not be uncountable. ये वर्ड्स बहुत इंपॉर्टेंट है गाइस, एग्जाम के लिए डायरेक्टली एग्जाम में आ सकता है, ये चांस है. क्लियर? या राइट. अनडिसाइडेबल को कैसे यूज करना और अनकाउंटेबल को कैसे यूज करना, नॉट एन्यूमरेबल को कैसे यूज करना. Not enumerable doesn't, it's the same as just not real. Do not confuse this word. Okay, so I hope this information is sufficient for the exam point of view, and I'm going to help you a lot. But in future they might ask any question, guys, and these examples we are going to practice in coming Saturday and Sunday, and so many examples are there to understand. And guys, I'm going to plan from Monday onwards, every day 4:30 p.m. every day 4:30 p.m. we will have GATE PYQ sessions year wise. Already I started GATE PYQ session every day. Keep attending and you will be understanding how to apply this knowledge on the questions. Just attending the lectures not 100% enough. You need to have a good practice. So every day we are going to practice any concept which is not covered. In case I'll be covering in the GATE PYQs too. So I want you to attend Monday onwards, every day 4:30 p.m. We will be having Monday to Friday. Already 3-4 sessions are completed, and 4:30 p.m. to 5:30 p.m. 1 hour session for GATE PYQ session on TOC. So please attend this session to know about the all the concepts in TOC. And somebody want how to face. I'm going to help you guys how to face GATE exam. Good. For the TOC, I'm talking about TOC, guys. Especially I'm talking about TOC. And be good at regular expressions. Regular expressions are very, very important, because every regular language infinite answers are there. So they could frame any regular expression in the exam. Second, focus on minimum DFA. Practice as many as possible. Construct randomly minimum DFAs for standard problems. But that should be done within 2 or 3 minutes. If any minimum DFA taking 10 minutes, 20 minutes, we don't prefer. 3. Identify Languages, that is the most important, guys. Identify languages. Like, is it finite or is it regular? Is it DCFL or is it CFL or is it recursive or is it REL or is it not REL? Anything is you have to be good at. And fourth one, look at closure properties. You can make a shortcut for all of them. Closure properties for all domains that I have explained in the class, guys. Closure properties for all domains. 2 points you remember, the subset and infinite operations like infinite union intersection. They are not closed for the most of the domains that we have studied. Most of the domains. And fifth one, study clearly undecidability, because it's going to be deciding 1 or 2 marks minimum. Undecidability concepts only will help you to answer the questions. Okay, in coming sessions, I'm going to help you most of the concepts in undecidability, guys. You may assume it is just a begin. Even the course ends, but practice not going to end for the coming 10 to 15 days, guys. Yeah. Everybody? Those people who are good at finite, because finite you don't need a knowledge. You don't need a knowledge. If you are good at undecidability, you are good at TOC. Remember that. Because undecidability will help you how to understand the words. Not the finite beta. Finite beta you are remembering it. Because there is no memory required to solve that problem. Very easy. Fine. Okay. Please work on these points. These are going to help you. And next one that is important for CFGs. For both compiler and CD. CFG. Practice as many as CFGs to identify the language. Identify the language generated by given context-free grammar. That is another important one for the GATE exam, guys. Because compiler design and TOC common topic. And if you look at the weightage here you can expect 8 or 9 marks in GATE based on the previous analysis. Sometimes 7, sometimes even more than 9 also. But this is average I can predict in TOC. In TOC you can see that 8 to 9 marks. Yeah, already I have shared today classes happened. Short notes on TOC. So please go and find on my profile. You will see that. Short notes. Okay. Yeah. Tomorrow you can meet me at 8 a.m. guys. Tomorrow you can meet me at 8 a.m. The strategy for first, last 1 month preparation. I will help you, how to prepare for the exam. But this is on Unacademy. Unacademy special free class. And 2 is another free class, 9:15 a.m. There is complete strategy on compiler design for those people who are preparing for GATE 2022 and 2023. And 11 a.m. is a plus course. It is not for the free people, guys. Okay, this is tomorrow's session. Yeah. And we are going to see a lot of interesting sessions on TOC. But look at in the crash course, we have completed the TOC. But 1 or 2, 3 topics I may be covering in the practice sessions. Please follow me to learn the complete TOC because you require practice. You might be learned very quickly TOC, but you need to practice a lot on TOC to get a confidence, guys. So that confidence I'm going to help you. Everybody? Yeah. And you can go to playlist. You can find TOC, compiler design, C programming. All playlists are completed, guys. And you are going to get so many interesting sessions in future, and we will be announcing soon. Remember that. You will be surprised with the next coming sessions, and wait for the announcement. You will be enjoying our sessions in the coming month too. Okay. I'll be meeting on Sunday again for TOC practice. We have on Sunday I think 8 p.m. to 10 p.m. guys. On Sunday we will have a special session. Practice on TOC, guys. Please attend this. Practice on TOC. Right, we are going to practice the whole TOC and not one class. I'm going to help you in many classes. Yes. Everybody? Yeah, thank you, Shubhasri. Thank you so much. But still some topics are there. I will help you in the coming practice sessions, guys. Everybody? Yeah. See you guys. And in case if you need my help, you can follow my profile. And in case you are not visited Unacademy yet, visit and use DEVALIVE referral code to access the free classes. And in case if you want to take the subscription, you can use this referral code. And if you have not subscribed to our Telegram channel Unacademy GATE CS, it is a Telegram channel you can subscribe. Use this URL and click enter in browser. You will get an access to join. And you can share all these free YouTube channels which are very popular and all are from Unacademy, which are free YouTube channels. You can share with your friends, guys. And thank you so much everybody, each and everyone. Please like this session and don't forget to give your feedback, which will help us a lot. Remember that. And share with your friends if you have learned something from us, and subscribe if you have not yet done. Thank you so much, and we will be coming up with more interesting sessions. As I said, I am promising you that you will enjoy more sessions in future, because we are going to come up with a lot of interesting practice sessions. Remember that. Okay, please keep visiting this channel and don't forget and follow every other class which you are preparing for the GATE exam. On this channel, I will be coming back with a more interesting session